Hello, everybody. Good morning. Hope everybody's fine.
Good morning, sir.
Good morning. Good morning. So, how many of you we have? We have only 7 of you. Wait for 2 more minutes. Let your friends join. Okay, guys, are you ready? Shall we start? I hope if we have enough people now, I think we have 10 of you. Right. Shall we start? Everyone ready?
Yes, sir.
Okay. Fine. Right. Okay, let me share my screen. Sir, I'm not able to hear you. You will join. You'll rejoin. Is everybody okay? Everybody able to hear me? Only Anandita is having the problem.
So for me, it's clear, sir.
Okay, fine. You're able to hear. Okay, cool. Right. Right. Where is the where are the points? Here. Right. Okay. So these were the points, right? So today we'll start with group 16, right? See, there might be more questions which can be asked, but 99% of area we have covered in group 15. Okay, and I hope everybody has taken down every question. I'm telling you, if you have taken down the questions, if you have taken down the answer, you do not have to go through the chapter again. I'm telling you, this is a very big chapter to study. Okay, so if you just have the questions and answers with you, obviously it's not like you're mugging up. You know the questions, you are understanding the logic, then you're answering the questions. That's what is always better. Okay, I hope everyone, even if you have not copied down, take the questions from other groups and you must have all the questions, all the answers for all the groups which I've asked. Okay, be very careful with that. If you're not going to do that, again, the loser is going to be you. Like, you're going to have to just study that big chapter all by yourself. Nobody will be able to help you there. Okay, so today the first question goes to group 1. Okay, let me check every group. Is there group 1? Is there, guys? How many of you are there? Group 1? Group 1? Are you there, group 1?
As of now, 2 members are there, sir. Anandita left now, and 1 person is absent, sir.
So, okay, 1 person, now 2 people are there in this thing, right? Okay, in group 1. Okay, group 2, are you there? Group 2? Nobody's there in group 2? Or you forgot the group members? Guess what happened? Is anyone there in group 2 or nobody is there? Sorry?
2 of us are present, sir, and the other 2 are not.
2 are, okay, no problem, no problem. I just need to know if people are there or not in particular group. Okay, group 3, how many of you are there?
Sir, everyone is there, sir.
Everyone is there. Okay, good. Group 4?
Sir, I am the only person, group person.
Only Rohan is there. Who's that speaking?
Sashank.
Sashank. Only Sashank is there. Only Sashank is there. No problem, Sashank. You prepared, right? Did you prepare?
Yes, sir.
Good. Then you can manage. Not a big deal. Okay, fine. So we'll start. The first question today goes to group 1. Right, group 1, your question is, why does O3 acts as a strong oxidizing agent? Right? Why is it that O3 is able to perform as a very powerful, acts as a strong or a very powerful oxidizing agent? Why? Your question, your time starts now to answer this question.
Sir, O3 is endothermic, sir.
O3, what do you mean by O3 is endothermic?
It releases energy, sir, and it decomposes when we heat it, sir.
Okay, so?
To give O2, sir.
Okay, so?
And this O2 is very reactive. So therefore, you can say it is oxidizing.
No, not exactly. We cannot, it's not because of it decomposes to O2, but it's
Sir,
not because of that it is an oxidizing agent.
Sir, and ozone is a very stable compound, sir, under room normal conditions, and it decomposes to give oxygen, and another like O3 gives O2 plus O, sir, and
Okay.
that O is a free radical compound, and it is very reactive. Therefore, ozone is very powerful.
Okay. Your answer is correct. I mean, it's not like say 100% correct, but still 95% correct. So I'll give you the mark. So group 1 gets +2. Right. So what you have to understand is people, right? You have to tell the answer like this. Ozone, O3, is having very less bond enthalpy. Right, O3 has very less bond enthalpy. Means what? It can now I can easily break the say you know the structure, right? Ozone will look like this. Okay, now this bond is very weak. Okay, this O single bond is very weak. So what can happen? Ozone will decompose to form O2, and this you should not tell O, you should tell it as nascent oxygen. You must tell it like this. This is the term which you have to use. Okay, ozone will decompose to form oxygen gas, and O3 will decompose to form oxygen gas and nascent oxygen. And it's because of this nascent oxygen, O3 acts as a very strong oxidizing agent. Right? It is because it's not because of O2, right? It is because of this nascent oxygen, O3 can act as a very strong oxidizing agent. Okay, you must start with this. O3 has less bond enthalpy, so it can dissociate or decompose to form this reaction, and the strong oxidizing property comes from the nascent oxygen and not from O2. Okay, this is how you must answer the question. Okay, good attempt. Fine, we'll move on to the next question. Next question is for group 2. Okay. Okay. So the question is, I have oxygen and sulfur, right? Which has higher electron gain enthalpy and why? Right? Which has, I mean, when I say which has higher negative value of electron gain enthalpy and why? Okay, among oxygen and sulfur, right? Which has higher negative value of AGE is electron gain enthalpy, and justify your answer. Why is it like that? Question to group 2.
Sir, what is that EHE, sir?
Electron gain enthalpy. First of all, obviously, you must know what is electron gain enthalpy. Then only you can answer this question, right?
Excuse me, sir.
Yeah, tell me.
I wanted to inform I joined.
Oh, Rohan. Okay, Rohan. So your teammate was alone. So now he has some company. Good. Nice.
And sir, what was the question? I joined this meeting.
Question is, I have oxygen and sulfur, right? Among this, which has higher negative value of electron gain enthalpy, which has higher value, higher negative value, and you must justify the answer why. Why is it like this? Okay, any answers, group 2?
Sir,
Yeah,
sulfur has more electron gain enthalpy
okay, fine, correct. Why?
because oxygen is in small size. We cannot add more electrons to it.
Okay, oxygen has small size, so we cannot add more electrons. Can you come up with a better answer? Oxygen has small size. Why we cannot add electron to that easily if I have a small size? Why is it that when I have small size, it is difficult to add? It is not because exactly of small size, but still, what reason can you come up with for that? Yes, you want to answer? Or can I move on to group 2? I'll give you 1 mark for this because you answered it, but not 2 marks. So +1 for, okay, fine, right? You want to answer group 2? Any answers you have? Why is it that sulfur is having higher electron gain enthalpy than oxygen? Okay, so yeah, fine. Group 3, your chance. You can explain me why is it that sulfur is having more electron gain enthalpy than oxygen? Why is it like this? If you answer, you get 1. Yes, group 3, any answers? Okay, so I conclude that nobody knows the answer. Anybody else wants to answer? Yeah, tell me.
So I'm from group 2. May I continue?
Group 2, your chance is over. Fine. Okay, go on.
So is it due to the repulsion between the electrons in this one?
Okay, repulsion between electrons. Can you? It is something has to do with repulsion between the electrons. But can you explain properly why oxygen has lesser electron gain enthalpy, even though oxygen is more electronegative, right? Comparing electronegativity, if I check, oxygen is more electronegative than sulfur, but I don't know how long I was speaking, but my internet went. Right, I think I'm speaking for 5 minutes, explaining stuff, asking questions, and at the end, I came to know that I was speaking to myself. Right. Anyways, so is everything okay now? Are you able to hear properly, guys? Is everything
Yes,
fine?
sir.
Yes, sir.
Okay. Right. Let me share my screen. Oh wait. I think someone else is the host. Who's the host? Epsilon Academy is the host. I think they have to make me the host again. Yeah, made host. Okay, great. Now I can share my screen. So what I was asking you people is, right? So what I'm telling is, I know oxygen is more electronegative than sulfur. Oxygen is more electronegative than sulfur. All I'm asking is, what do you mean by electronegativity? What is electronegativity? First of all, then we'll see what is electron gain enthalpy. Then we'll answer this question. Okay, tell me, how do you define electronegativity? I'm there, right? Again, I'm not talking to myself. Hopefully, yeah, I am there. Right, yeah. So yeah, what do you mean by electronegativity? How do you define electronegativity, people?
It's the power by which atom attracts an electron when it's in a shared pair with another.
Tendency of an
Correct.
atom.
What? Tendency. Oh, correct. Yeah. So basically, how do we define electronegativity? It's a tendency of the element or atom, for that matter, to attract a shared pair of electrons. Shared pair of electrons. So it's very simple to understand. Say, for example, let me take H2O, for example, water. Right now, I understand that this particular bond, there are 2 electrons shared here. In this bond, 2 electrons are shared here. Right. Say now, when I take H2 as an example and compare it with this, right here also I have 2 electrons. Okay. Now, what will you understand is that this electron pair, which is here, is going to be at the exact center between these 2 nuclei. Right. But in this case, since I have oxygen to be more electronegative than hydrogen, these 2 electrons are going to be more towards oxygen. I'll write like this. Okay, again, same way, these 2 electrons are going to be more towards oxygen, not in the center. Here in this case, it is the center. Okay, because in this case, both are equally electronegative. Okay, but here, since one of the element, that is my oxygen, is more electronegative, right? You will see that the electron pair, the shared pair of electrons, is going to shift towards oxygen. Okay, now because of this, what is going to happen? I will have, if I write like this, right? Now, because the electron pair is going towards oxygen, oxygen will possess a partial negative charge, and both the hydrogen atoms will possess a partial positive charge. Because electron cloud is moving away from hydrogen and electron cloud is moving towards oxygen, I'll have a partial negative and partial positive on oxygen and hydrogen respectively. Right now, this ability to attract the shared pair of electron is this, the ability is what is called as, or tendency is what is called as my electronegativity. Right, or in other words, I can tell that it is the ability to form a negative charge or a negative ion, basically an anion. Obviously, right, more and more is the ability to attract electron. Obviously, more and more is the ability to form an anion. Is it not? Right? So now this we understood. What do you mean by electronegativity? So what we are trying to say is that oxygen has more capacity to attract a shared pair of electron than sulfur. Right? But when I look into the electron gain enthalpy value, oxygen is having a lesser EGE value when compared to sulfur. Right? Now, why is it like this? Right now, what you have to understand is, people, right now, we generally say even this negative value of electron gain enthalpy, right? So first we'll try to define what is electron gain enthalpy, then we'll try to understand why this happens. Okay, please take down the definition, people, for electron gain enthalpy. I'm giving you the definition for electron gain enthalpy. Please take it down. It is the energy released. It is the energy released or absorbed. It is the energy released or absorbed when an electron is added, to the valence shell, of a isolated atom, to the valence shell of an isolated atom. Isolated means that atom is alone. Okay, there is no atom nearby it. Okay, I hope you all get the point. I'll just repeat the statement, people. It is the energy released or absorbed when an electron, one electron, is added to the valence shell of an isolated atom, for that matter. Very simple, right? Say what you have to understand is, now when I have say an atom A, right? Now, depending on how favorable the condition is, right? Depending on how favorable the condition is, when I add electron to this, right? I can either have say positive value or a negative value. Now, when I say a positive value of energy in chemistry, that means energy is absorbed. Right? And whenever I say a negative value of energy in chemistry, that means energy is released. Okay. Now, whenever I have a negative value of EGE, that means energy is released when I add an electron. And whenever I have a positive value of EGE, that is electron gain enthalpy, that means energy is getting absorbed for the electron to get added. You have to supply energy for the electron to get added. Right? Now, why certain times energy gets absorbed, why certain times energy gets released is very simple. It's all about whether I'm getting stability or not. Right? Now, if say I have oxygen accepts one electron to form O minus, it actually becomes stable. Right? Obviously, one more electron you add, it becomes O2 minus, it becomes again more stable. Right? So whenever it becomes stable, we don't have to do anything. The reaction will happen on its own. So obviously energy will be released. Right? But say I take any metal, for example, say I have sodium. I'm trying to add an electron to form sodium, to form Na minus. Right? Now for this reaction, you have to supply a lot of energy. Why? Because Na minus is very highly unstable. Is it not? But O minus or O2 minus in this case is highly stable. So energy will be released in this process. How do you gain stability? By losing energy. Is it not? Only if the energy gets dissipated out, right? The atom will gain more and more stability. Right? Now, this Na minus is unstable. So we are going from a stable state to an unstable state. So compared to Na minus, sodium is stable, guys. Okay, so we are going from a stable state to an unstable state. So obviously energy will be supplied. In this case, it is EGE and it will have a positive value because it is unstable. Okay, now we understood what do you mean by electron gain enthalpy. It is the energy absorbed or released. Obviously, it will be positive or negative, right? Depend when I add an electron to the valence shell. Very, very simple. Okay, now obviously one thing to look is for stability, obviously if it becomes stable or not. Right? Now, other thing you have to look into is the easiness or say the feasibility of adding an electron. Right? Now, if the adding electron process is very easy, right? Okay, it is becoming stable. Say if two elements are there, both the elements are having negative value of electron gain enthalpy in the sense that both the atoms are becoming stable when I add electron, but still they'll be having some difference. Say in the case of oxygen and sulfur, right? Sulfur gives out more energy than oxygen. Right? So it is not like O minus and S minus. If I compare, S minus is more stable. No, O minus is the one which is more stable. No doubt about it. Okay. But as you said, where oxygen atom, if you check, it's very small. Right? Oxygen atom is very small. So what I'm trying to tell you is there is high charge density. High charge density of oxygen. This is the reason, right? Now understand, try to understand this. Okay, say I have India, I have China. Okay, now compared to China, India is a smaller country. Okay, compared to China, India is a smaller country. Okay, now China obviously has more population. Now look at this. I have a big country like this, and I have a small country like India. Compared to China, obviously India is smaller. Okay, now say here I have 100 crore people, and here also I have 100 crore people, right? I'm assuming that the population is same. Obviously, the population of China is higher, right? Say if I have almost same population, only it's not much different in between India and China. Right. So in a big country having 100 people, in a small country having 100 people, say I have to add 1 crore more people here, and I want to add 1 crore more people here. Right. So obviously, in this case, in India, if I add 1 crore more people, it is going to become more congested. Right? It is going to become more congested because already space is less and we have 100 crore people, but such a big country having 100 crore people is okay for me. Right? So this is where I say something called as population density. Right? So population density is nothing but the amount of population, POP, divided by the area. Right? In a particular area, how many people are there? Obviously, even though China has more population, India has more population density. Smaller area, bigger amount of people, large amount of people. Right? So now if you understand, if I already have so much population density, adding more people to the country will become more and more difficult because it's going to become more and more congested. The people will say, no, we don't want to take it. They will repel this 1 crore people. Right? Now, same thing will happen in the case of oxygen also. Since oxygen atom is very small, right? Now, if I'm going to add electron here, already the electron is so much congested, right? So the electrons which are inside and the electrons which are coming here will undergo repulsion. Right? So because of this repulsion, it becomes more and more tougher for us to add electron into oxygen than in the case of sulfur. Sulfur, even though it is less electronegative, I don't have this particular problem. I don't have the problem of high charge density. Okay, that is why in sulfur it is little easy. So that means more energy will be released than in the case of oxygen. Okay, so how do you give a perfect answer to this question? You must tell that even though oxygen is more electronegative than sulfur, right, because of its small size and high charge density, you must tell this point. Okay, because of small size and high charge density, when the electron is approaching, I will have inter-electronic repulsions. This is how you step, right? I will have inter-electronic repulsion, so it becomes more tougher for us to add an electron, and that's why sulfur is having more negative value of electron gate enthalpy. Okay, this is like you understood what is electronegativity, what is electron gain enthalpy, and why is it that oxygen is having a lesser electron gain enthalpy, irrespective of the fact that oxygen is more electronegative. Okay, I hope every point is clear, absolutely clear to everybody here. Right? Now the same thing will happen in the case of your fluorine and chlorine. Right? I know fluorine is more electronegative, right? But when I compare the EGE value, chlorine will have more EG, more negative value of EG. Same reason, same exact reason. You should tell that fluorine is having a very small size, high charge density. So inter-electronic repulsions will be there. That is why it is easier to add electron in chlorine than to add electron in fluorine. That's why EG value of chlorine is higher than fluorine. Same thing, same exact thing. Oxygen, sulfur, fluorine, chlorine, same problem will be there. Okay, right? Fine. I hope everybody is able to answer. Understand this, whatever I'm trying to say. Okay, we'll move on to the next question. I think the question is for group 3, right? Okay, group 3, your question goes like this. Give a chemical reaction for me. Right, give a chemical reaction proving that SO2 can act as a reducing agent. Right, I want you to give me a chemical reaction, and in that chemical reaction, SO2 should act as a reducing agent. Give me a reaction like that. Group 3, your question. This is your question.
Sir,
Yeah.
sir, I know a reaction, sir.
Yeah, please go on.
Sir, 2Fe plus SO2 plus 2H2O gives 2Fe plus SO4 plus 4H.
2Fe plus SO2 plus H2O gives what?
2Fe plus SO4 plus 4H. This is when SO2 acts as a reducing agent.
4H. Is it just SO4? Is it just H? Is it just Fe? Are you sure about this?
So sorry, sir. It is Fe3 plus,
Hmm.
and then the product side, the Fe will be 2 plus, sir.
Okay, good.
And
And
then
what
the
about
2 minus.
SO4 2 minus? Okay.
So then 4H H should be 1 positive, sir. This one.
Okay. Fine. The reaction is okay. Can you tell me how in this case SO2 is acting as a reducing agent? It is reducing what?
Sir, it is reducing oxygen, sir.
It is reducing oxygen.
It's taking oxygen that, oh sorry, sir. It is reducing hydrogen.
It is reducing hydrogen.
Yes, sir. It's taking the oxygen from.
Okay, I understand. It is taking oxygen away from hydrogen. But what you have to understand is, Kana, this H plus and H2, SO4 2 minus is nothing but H2SO4. This one.
Yes, sir.
Okay. So what it is reducing then? Height is not the hydrogen is not the answer. SO2 is reducing what?
So is it Fe ion?
Okay. How? How is it that it is now? Can you prove that to me? It is undergoing reduction. Ion is undergoing reduction here. How is it undergoing reduction?
So by taking one so is it
What's
taking
happening
one
here?
proton?
What's happening here? Fe3 plus to Fe2 plus what is happening?
Sir, reduction.
Basically, by reduction means what? How do you say it's reduction?
Sir, because one proton is sorry, sir. Yes,
Do we
one
talk in
proton,
terms of protons?
electrons.
Okay. If we speak in terms of electron, then what is happening here?
So one electron is being gained.
Correct. Here, one electron is getting gained. So obviously, it is reduction. Please remember, people, addition of electron or gain of electron is reduction. And the opposite, removal of electron is oxidation. You see, Fe3 plus accepts an electron to form Fe2 plus. Okay. So obviously, that is where the reduction reaction is happening. So SO2, in this case, gets oxidized to SO4 2 minus. By that way, it is able to reduce Fe3 plus to Fe2 plus. This is how you must answer the question, right? So in a reaction, reducing agent undergoes oxidation. What is the oxidation here? SO2 undergoes oxidation to SO4 2 minus. How you can see it is +4 oxidation state of sulfur here. Here you will check it is going to be +6 for sulfur. Right, so sulfur can easily go into +6 oxidation state. So if I ask you the same question in a little different way, I can ask you how SO2 can act as a reducing agent. You must tell it like this: SO2 can undergo oxidation. SO4 2 minus. Right here, the oxidation rate is +4. Here it is +6. So since it can undergo oxidation, it can be a reducing agent. Okay, it can be a reducing agent. This is how I must answer the question. Okay, anyways, good. Right, I'll give you the points for this. Okay, so group 4, your question coming on the way. Okay, right. The question is, right, when I compare group 16 elements with group 15 elements, okay, we saw already about group 15, right? Now we're talking about group 16. So when I compare the first ionization energy, right? When I compare the first ionization energy of group 15 and group 16, right? Generally, what happens? Generally, when I go from left to right of the period, say I have lithium, beryllium, boron, carbon, like this, if I keep on going, right? What happens to ionization energy? It increases or decreases? We'll come back to this question later. Answer this question now. It's not group 3's question. Anybody can answer. When I go from period left to right of the period, what happens to ionization energy? It increases or decreases? Anybody can answer.
Sir.
It increases. Very simple, right? Why? Because I know size decreases, right? When I
Yes,
go to
sir.
lithium to beryllium, size decreases. So when I have, say, a smaller electron, I mean, this electron which is little close to the nucleus, and I have electron which is far away from the nucleus, obviously removing this electron is easy. Hope you all know what is ionization energy. It is the energy required to remove one electron. Okay, it is the energy which you have to supply to remove one electron. Okay, right. So now removing this electron is tough. So I have to supply more energy. This electron is little easier. So less amount of energy is required. Right. So now when I go from left to right of the period, right, we know that the size decreases, right? So when the size decreases, the valence electron comes closer and closer and closer to the nucleus. So it becomes more and more difficult to remove the electron, in the sense that I have to supply more and more energy for the electron to come out. So that's why we say when I go along the period, right, ionization energy increases. It becomes more and more tougher for us to remove the electron. Right. So if that's the case, I know I have nitrogen here, oxygen here. So oxygen should have a greater electron gain enthalpy, or say this entire group, nitrogen family, oxygen family, this entire group, oxygen should have more than nitrogen. Say sulfur should have more than phosphorus, right? But what we see in reality is that group 15 is having more ionization energy than the group 16, the first ionization energy. Okay, so the question is, even though along the period in general, ionization energy increases, right? But when I compare group 15 and 16, right, group 15 is having a higher ionization energy, first ionization energy. Why?
Sir, can I answer?
Your group 2, group
Yes,
3?
sir. Group 4.
No, this is for group, this is for group 4 only, right, this question?
Yes, sir. So I'll answer.
Okay, yeah, sure.
So because of the configurations, the group 15
Okay.
has NS2 and NP3. It's half filled, so it has extra stability.
Okay.
Whereas for group 16, it's NS2 NP4. For half filled orbitals, it will be more stable than.
Absolutely true. Right, very good answer. So you understand group 3 for nitrogen family, you will see that I'm going to have NS2 NP3, right? And for group 16 elements, you will find that I'm going to have NS2 NP4, right? So now, even though the size and all is okay, size of obviously group 16, oxygen is smaller than nitrogen, obviously. I find that's completely all right. But what you have to understand is, I have this NP3 configuration. Whenever you have half-filled configuration, right? Whenever you have half-filled configuration, P3 or D5, right? D again can have 10 electrons, but if I have 5 electrons, like that. Whenever for S, it will not work. Right, for S, if you have S1, it doesn't matter. That is not the case. Okay, but for P and D, this half-filled stability works. Whenever I have half-filled configuration, that becomes more stable. Okay, so if it becomes more stable, and now that the amount of energy which has to be supplied for me to remove the electron becomes higher. Okay, so the answer to this question is, it's because of half-filled stability. Group 15 has more first ionization energy than the group 16. Yes, that's the answer. Did I give you the point already? No, right? No. Okay, so +2 for group 4. Right. Okay, your next question for group 1, I guess. Right. Now your question is, arrange hydrides of group 16 in the order of thermal stability. Right, the question is, arrange the hydrides of the group 16. You know what are hydrides, right? Can I call them as hydrides? Fine, okay, no problem. Arrange the hydrides of group 16 in the order of their thermal stability. This question is for group 1.
Sir, H2O is the maximum, sir.
Well, first of all, okay, tell what is the answer? H2O?
H2 has the maximum thermal
Okay.
stability, sir, and
Okay.
H2TE has the minimum
Okay, H2TE has minimum stability. Okay, so in between what all elements I have? I know the answer is okay.
Sir,
Just want to
sir,
know.
so the first is H2O, sir. Second is
Hmm.
H2S.
Okay,
Third is H2SC, sir. Fourth is H2T.
okay, fine, correct. H2SC and then H2TE, fine. Why?
Thermal stability decreases down the group.
This is not how you answer, right? Thermal stability I decreases down the group. Okay, why it decreases?
From group
Wait,
one,
wait,
sir.
wait. This is group one, right? Wait. Even if they miss, they'll go to
Sir,
group
because the
two.
bond breaking energy also decreases down the group, and the nucleus increase. Sir.
Okay. This I can accept. The
Central
bond
atom
energy.
size will increase, sir.
Wait. We'll come one by one point. Bond energy decreases. Basically, OH bond is stronger than SH bond, than SCH bond. This bond is stronger. That's why obvious stability high. Now go on. What is going to happen with size and bond energy? What
Central
happens?
atoms will increase, sir.
Central atom size will increase.
Yes, sir.
So
Bond dissociation energy will decrease, sir.
okay, I will give you the point for
The
this.
force of attraction between the nucleus and the valence electron will also decrease, no, sir.
Okay, your answer is correct. I will give you the point, but this is like not 95% correct. Okay, but not fully correct. Let me give you the answer then. Right? Yeah. Obviously, the order is like this. Okay, down the group, the step Hello, people. Are you guys there?
Yes, sir.
My electricity went, so I joined through my phone. I don't know how am I going to teach you. Like I can ask you the questions, but how will I explain you is the problem. Like how will I explain the answers by writing and stuff? I'm in Bangalore also. If I was in Chennai, I would have got through the board. I have a board, right? You must have seen. So that could be done. So what can I do here? Tricky situations, right? Fine, guys. I think you guys can leave. Okay, we have only 45 minutes of class today almost. We will try to compensate this by say tomorrow. Are you guys free? Guys, tomorrow, are you guys free? Tomorrow, can we have a 1 hour class? Is it okay?
Sir, it depends on the time.
Okay, I would prefer say morning. Tomorrow morning, say 8 o'clock or 7:30, 7:30 to 8:30.
Sir, I have extra classes, sir.
You have extra classes. Or how about evening then?
Sir, evening we have physics.
Oh,
From 6 to
Sir
7.
may conduct physics or max class, sir.
okay, okay. How about today evening?
Sir,
Today evening?
Also, I have tuition, sir.
Okay, fine. The current is also not coming.
Sir, you can join with hotspot, no, sir.
No, that's not the Wi-Fi is not an issue. I can use my hotspot and do like laptop. There is no charge. The laptop got switched off. That's the main problem. So through laptop only, I can share my screen and I have this, this slate on which I write, and you'll be able to see them in the screen. But that is not there. But let me check. Let me check if I can do it in. Wait, actually, I have an idea. 1 second, guys. Hold on. Guys, are you able to see the whiteboard?
Yes, sir.
Yes, sir.
Okay, 1 second. I really hope that this should work. What I'm trying to do. 1 second. Where's my pen? Please work. Please work. Okay, I'm able to see the cursor moving, but great. Okay, technology. Thanks to technology. Okay, fine. Okay, guys. How do I go to that side? Okay, fine. So what question are we discussing? We were discussing about, I think, which question are we discussing, people? Any idea? Oh, the thermal stability, right?
Thermal stability of
Okay.
hydrides
So
of
thermal
group 16.
stability, I told it is H2O, then comes H2S, then comes H2TE, sorry, H2SC, then comes H2T. right? Okay, guys, is it clear for you whatever I'm writing? At least little bit clear.
So you can use another color, sir.
Another color. Okay, that is okay. That is okay.
Sir,
This is fine. Red?
Yes, sir.
yes, sir.
Okay, right. So what I'm trying to say is, why is it that this will be the order of this thing? All you have to understand is, people, I told you that bond decision energy decreases down the group, right? I am trying to tell that the OH bond is more stronger than a SH bond. Now, why is it happening like this? Is because of size difference. Okay, not only in this molecule, people, right? Any molecule you have, right? Any molecule. Now, if the difference in size between the atoms, say I have two atoms A and B, right? Now, if say both of them are small or both of them are big, right? Both of them are small or both of them are big, it's okay, right? But if one of them is very small and the other one is very big, then it becomes unstable. Okay, then it becomes unstable. So all you have to remember is about the size difference. Okay, so size difference, higher the size difference, less will be the stability. Smaller anion, smaller cation, stable. Bigger cation, bigger anion, stable. But bigger one, smaller one, unstable. Okay, so what happens here? The size increases like this. Is it not? Oxygen is having lesser size, sulfur is having more size. So the size difference between sulfur and hydrogen increases, increases. So obviously the stability decreases because the bond energy decreases. That is how you must answer the question. Okay, right? Guys, remember the points. Okay, I don't know whether I'll be able to write points here. Okay, so I think the question was for group, which group was the question came? Group 1?
Yes,
Was
sir.
it? Okay, group 1's question. So remember the points, okay? Right, I cannot write it, and tell me in next class what are the points. Okay, next question for group 2. Now, let me rub all this. Okay, right. So the question is, H2O is a liquid, but H2S is a gas. Why? H2O is a liquid, but H2S is a gas. Why? This question goes to group 2. Okay, group 2. Any answers?
Sir, is it due to stronger hydrogen bonding?
Yes, absolutely. Which has stronger hydrogen bonding? H2O or H2S?
H2O.
Okay, right. So H2O has, the answer to this question is hydrogen bonding.
So I have a doubt, sir.
Yeah, tell me.
Sir, H2S doesn't have hydrogen bonding at all, sir.
Which one? H2S doesn't have hydrogen bonding. You cannot tell, like, yeah, we
Hydrogen
can
bonding
tell.
is for nitrogen,
Yes, yes.
oxygen, fluorine, and hydrogen.
Correct,
Right?
correct. It holds good, but that doesn't mean that, see, hydrogen bonding is what? Hydrogen bonding is a type of dipole-dipole interaction, right?
Yes, sir.
Right. So if you speak like that, yes, H2S still has dipole-dipole interaction, but we will not call them as hydrogen bonding. Right, but H2O perfectly has hydrogen bonding. Obviously, this hydrogen bonding, and that's why she said hydrogen bonding is stronger here, and the dipole-dipole interactions are weaker here. That's what I exactly say. So the perfect answer would be that H2O, in H2O hydrogen bonding is present, in H2S hydrogen bonding is not present. So since I have hydrogen bonding, that makes it a liquid. Higher in intermolecular forces are very high, but H2S, the intermolecular forces are not that high, so it becomes a gas. Okay, so yeah, give 2 points for the group. I'm not writing it, guys. Please write the points. Any one can maintain, right? Anyone just maintain the points. Rohan, can you do that? Just maintain the points of all the groups. Can you tell me next class?
So if I could know the score before this.
Exactly. Before score, group 1, what was your score? Now you got 2 points before this also. What was the entire score, group 1? Group 1?
Sir, I think it was 14.
I
Sir.
think we had 12, sir, and last question we had 2 points. 14.
So 14, right? So group 1 has 14, Rohan. Group 2 now has 2 more points. So now group 2 has how many points? Along with the 2 points now getting added, what is the point? Group 2. Yes, group 2.
Sir, I think it's 13.75.
13.75. Okay, group 2 has 13.75. Along with the questions too.
0.75 came, sir.
One question, it was not proper. So I gave you, instead of 2 marks, I gave you 1.75 because the answer was only partially correct. That's why. Okay, right. So group 3 has how many points?
13, sir.
Group 3 has already 14. Now the question is to you. Group 4 has?
I think we have 12 points.
12 points. Okay, remember all this now. Okay, so remember all this now. Maintain the points, and next class, please give it to me, or you can just send me in WhatsApp after we complete the class.
Okay, sir.
Okay, right. Fine. Your question for I think group 3 now, right? Group 3, your question is okay, I have to rub this all right. Okay, your question group 2, I mean group 3, which form of sulfur is paramagnetic? Okay, they have different allotropes of sulfur, right? Okay, different forms of sulfurs are available. One of them is paramagnetic. Which one is that? Group 3's question. There's a particular form of sulfur which exists in which shows paramagnetism, or which is paramagnetic. Just think about the question. I'll be back in a minute. Okay, 1 second. Yeah, tell me.
Sir, S2 will exhibit paramagnetism, sir.
Okay, so S2 will be in what state? Liquid, solid,
Sir,
gas?
vapor, sir. Vapor state.
Okay, correct. That's the answer to this question. Where is the stylus? Oh, here inside. Okay. So yeah, your answer is correct, right? You must tell that S2 vapor will be paramagnetic. Right now, what you have to understand is, people, how paramagnetism comes. Right, for substance to be paramagnetic, I should have unpaired electrons. Is it not? Hope you remember this, right? For anything to be paramagnetic, right, I should have unpaired electrons in them. Right now, if you have S8, generally sulfur exists in the form of S8, rhombic sulfur, we call it. Okay, this is not paramagnetic, this is diamagnetic only. Okay, but if I have S2 and vapor state, definitely it is going to become paramagnetic. Now, if you want to understand how do I have an unpaired electron, please go for this thing. What is that? Please go for molecular orbital theory, right? So if you fill for O2, I know O2 is paramagnetic. If you can remember from your chemical bonding chapter previous year, right? O2 is paramagnetic because you will have pi star 2px1, pi star 2py1. Hope you remember this, 2py1 and 2px1. Now, since you have these unpaired electrons, okay, O2 is paramagnetic. So obviously S2 will have the same kind of configuration, right? It will also have pi 3px1 and pi 3py1. That's the only difference, but still there are unpaired electrons here. Okay, that is why we say that S2 becomes paramagnetic. So yeah, give +2 to group 3, Rohan.
Yes, sir.
Okay, right, thank you. So next question for group 4. Right, again, I have to rub this. I really hate this software. So can we move this? No, right, not possible. Okay, this space is sufficient for me to ask the question. All right, your question is how SO2 or how presence of SO2 is detected. Okay, the question is, how is the presence of SO2 detected?
So you mean like a test for it, sir?
Yeah, correct.
Is it because of the smell, sir?
No. There is a proper test
Sir,
which you will
sir,
do.
I think it's formed by roasting of sulfide ores.
Oh, no, okay, that is blister copper, right? That is different. That is entirely different. The copper will have kind of blisters because of the evolution of SO2. Not that. No. In lab, if you want to say some gas is coming out and you want to check whether that gas is SO2 or not, what will you do?
By treating sulfite with dilute sulfuric acid.
Dilute sulfuric acid. Okay, what happens if I add dilute sulfuric acid?
So if you add SO3 2 minus aqueous, it should be in aqueous solution.
Okay.
And plus 2H plus aqueous gives water in liquid form plus SO2.
Okay, fine. The reaction might or might not be correct, but how will you detect that is giving me SO2?
So we add water to SO2, so it will again give sulfuric acid. So if it gives sulfuric acid again, we can identify as SO2, right, sir?
You can, it can form sulfuric acid. Say, now I understand that, say you can go for some pH and determine that is an acid, but same thing can be done by N2O also. N2O, when I add water to N2O, it forms nitric acid. Say I have carbon dioxide, you add add water to carbon dioxide, it is going to form H2CO3, again acidic, right? So even though theoretically what you're telling is correct, so many other gases can do the same confirmatory test, right? Hope you understand the point, what I'm telling, correct?
Yes.
Right? So
Can
then
we
how you
get
do
some
it?
more time, sir? You think?
Yeah, maybe you can take 1 more minute. It is there in your books. Maybe if you studied your book properly, you will get the answer to this.
So we can see if like it's reducing and oxidizing action. So,
Why not? Why not? Please go for it. That is what is expected.
so in moist condition acts as a reducing agent, sir. Like
Okay.
in the previous question we saw Fe plus SO2
Absolutely.
plus
Absolutely.
water will give.
Correct. Correct. Okay. So how can we use this here? Think about, okay, I'll give you a clue, even though this question I understand is a little tough. Think about a redox reaction where, or I would say think about a redox titration where, say, one of the reactant itself will act as an indicator, self-indicator. Think about it.
Could you repeat it? What you just said?
What
now,
I'm
sir?
telling is, obviously, say for an acid-base titration, right? For me to understand whether the reaction is completed or not, we go for an indicator, say phenolphthalein or something, right? Right? So like that, when I go for redox reactions, right, and I want to check whether the reaction is completed or not, sometimes you go for indicators, but sometimes the one of the reactant itself can act as an indicator. That means initially the reactant will be in one color, but when the reaction gets over, it is going to change its color. Can you remember anything like that?
Potassium permanganate.
Okay, KMnO4 is potassium permanganate. Okay, fine. What happens here? Potassium permanganate, if I add with SO2, what happens?
The reaction will be.
Okay, first
There will
tell
be
me,
a color.
wait, KMnO4 is what color?
I think it's violet or something.
Okay, purple. Yes, it is violet. Okay, this is purple in color. Okay, now obviously this is a reducing agent. I know this is an oxidizing agent. Everybody knows KMnO4 is an oxidizing agent. SO2 is a reducing agent. So obviously redox reaction is going to happen. So now we'll come back to KMnO4 later. Tell me how SO2 will get oxidized. SO2 will get oxidized to what? Now only we saw. What is it?
Sulfur, sir.
It will get oxidized to what? We saw Fe3 plus reaction, right? What happened there? For SO2 became what?
So for 2 minus, sir.
Correct. Okay, now this doesn't give me any color change. This and this are same color. The answer is here. This will convert to what? Plus what? Okay, assume that it is happening in acidic conditions. Right, obviously, I hope you remember, if I have acidic, basic, and neutral conditions, they have different products for KMnO4. Assume that this is in H plus acidic condition, then what will be the product here?
Yeah, 4H.
Sorry?
It will be 4H plus.
No, forget about this. I'm talking about what will happen. This is in the form of MnO4 minus, right? Now say SO2 became SO4 minus oxidized. Now MnO4 minus has to get reduced to what?
KMnO2 plus.
Mn2 plus. That's it. I need, okay, I'll write it here at the top. It's going to be Mn2 plus. Then obviously you understand that this is going to be colorless. Okay, I don't have space, guys. It is not moving after this. Mn2 plus is colorless. KMnO4 will be purple in color. So now when the reaction happens, if there is SO2, right? So what will happen? This will convert purple colored KMnO4 Do you remember that? What is the other one?
Broke. We couldn't hear you for some time, sir.
Now is it fine?
Now it's fine, sir.
Yeah,
Like
so what
after
I'm
you were
asking-
saying about Mn2 plus, bro.
Okay, so basically Mn2 plus is colorless. So we understand that when the reaction gets over, the purple colored solution will become colorless. So we understand that SO2 is present. Like KMnO4, there is one more thing. There is one more kind of oxidizing agent which will act as a self-indicator. What is that? What is the other strong oxidizing agent other than KMnO4?
Reaction which we had, sir.
Yeah, like other than there are two strong oxidizing agents in chemistry generally, right? One is KMnO4, the other one is potassium what?
Dichromate.
Dichromate, sir. K2Cr.
Absolutely. It is K2Cr2O7, right? What is the color? K2Cr2O7. What is the color of K2Cr2O7? Potassium dichromate. What color is it?
I think it's orange.
Orange, yes, it is orange in color. Okay, let me rub some of the things. 1 second, let me explain the reaction. Oh God. Oh, I have to do the rubber, right? Okay, eraser is here. Okay, so now MnO4, even though it's the correct answer, I mean, it's one of the correct answer, a better answer would be to use K2Cr2O7. So use K2Cr2O7, take SO2, right? Now, obviously, SO2 will convert to SO4 minus, that is common, right? But what will happen to K2Cr2O7 is that K2Cr2O7, like here it says it's +6 for chromium, here it will become +3. Right now, here I told you it is orange in color. Cr3 plus will be green in color. Okay, Cr3 plus would be green in color. So you both the best, I would say, better reaction is this. Okay, take K2Cr2O7, make it react with SO2. The orange colored solution will become green colored solution. So if it happens, yes, SO2 can be detected. Okay, so your approach was very good, even though the answer I helped you, but still I give you 2 points because your approach is very good. Give yourself 2 points, Rohan, for group 4. Okay, I hope everybody got the answer. What we are looking for. What is the time?
11:05, sir.
11:05, 10 more minutes. Okay, fine. Maybe we'll go for one more round if possible. Okay, right. Your next question for group 1.
So the presence of Mn2 plus is what decides it to be SO2, sir.
What? In the presence of?
Since Mn2 plus is getting formed, we can say it's SO2, sir.
Correct. But the thing is, this is not a good way of looking at it because if it is going to be acidic condition, Mn2 plus will be formed. If it is going to be basic condition, MnO4 2 minus will be formed. And if it is neutral condition, MnO2 will be formed. So MnO2 will be black in color. Right. So
Yes,
like depending on the pH of the reaction, the color will be different. That's why MnO4 is not a good way to go about it. Right. But K2Cr2O7, it will happen only in acidic conditions. There is no other change. Right. So the only color change possible is from orange to green. That's it. This is a good method of doing it. K2Cr2O7. Okay. Right. Fine. So your next question for group 2. Now I'm just looking for a question.
So group 1, sir.
Oh, sorry, group 1. Sorry. Yeah, group 1's question. Okay, this is a very nice question. Let me see if you can answer this. Oh, God. Guys, I think current came back. Right. Okay, fine. Anyways, 10 minutes only there. Are there? Let me use this only. Why you have to waste time? Okay. Right. So what I'm trying to say is the question is for group 1, oxygen. I'm sorry. Yeah. Oxygen and chlorine. Okay, oxygen and chlorine, both of them almost have same electronegativity. Right? Almost, like even though obviously oxygen is more electronegative, but it is not that different. Okay, oxygen and chlorine have almost same. What happened? Right, they have same. Okay, same electronegativity, almost same electronegativity, right? But still, oxygen can form hydrogen bond, whereas chlorine cannot. Hope you understood the question. Group 1, they have almost similar electronegativities. Oxygen and chlorine have almost similar electronegativities. Okay, but oxygen is capable of forming hydrogen bonds, but chlorine is not capable of forming hydrogen bonds. Why?
Sir, chlorine does not form hydrogen bonding, no, sir.
Yeah, why?
Sir, oxygen has small size.
Okay,
And
so
more electrons per equal.
More electrons per.
We can say electron density also. We can say, no, sir.
Yeah.
Textbook.
Okay, that's understood. Yes, it is correct. Okay, oxygen has a smaller size, right? But chlorine has little bigger. So the charge density, the lone pair density is what we're looking at. Okay, since the lone pair density on oxygen is higher than that in the chlorine, right? Obviously, oxygen is able to form, chlorine is not able to form. And one more pakka, like your book might not tell you, but
small size of atom.
Yeah, that's what your book tells you, and yes, that is also a correct reason. But the exact reason, if you check, right now, you understand that the lone pair of electron is there in 2p orbitals. I have to clear this. Okay, so what I'm trying to tell you is that oxygen's lone pair is in 2p orbital. Okay, so when hydrogen bonding happens, right? Okay, so what happens? This has 1s, obviously the valence shell. Here the valence shell is 2p. Okay, so they have less energy difference, right? But when I go to chlorine, you know that in chlorine the electron is present in 3p. Okay, so 3p 1s is not a good combination. When the energy difference between the orbitals are too high, the bond will also not be that stronger. Okay, but here it is hydrogen 1s, oxygen is 2p is what is involving here. So that will have better hydrogen bonding because the energy difference between 2p and 1s is little less compared to the energy difference here. Here the energy difference is very high. Okay, that is the reason. So yeah, anyways, your answer is correct. Rohan, group 1 plus 2.
Sir,
Okay.
sir,
Yeah, tell me.
sir, I just have one doubt. So
Yeah.
this is the answer, sir, but can we give another alternate answer such a way with which relates to electronic configuration, sir?
How electronic configuration?
Sir, oxygen only needs 2 electrons to reach stable configuration, sir, whereas chlorine needs 1.
Okay.
So H2O will be more stable now, so it will take 2 atoms from.
Anyway, say if it is H2O or HCl for that matter, right? Oxygen requires 2 electrons, so it has 2 hydrogens. Chlorine requires only 1 electron, so it has only 1 hydrogen. Right? See, remember this. Like whenever we talk about hydrogen bonding, it is in between 2 water molecules. It is in between 2 HCl molecules. It's not between chlorine and hydrogen or oxygen and hydrogen. No, it's not like that. Right? I have one H2O molecule, another H2O molecule. These 2 H2O molecules will be together strongly held because of hydrogen bonding. Okay. For HCl, it won't happen. Between one HCl and another HCl, you will not have that strong interaction because of what I said. Like say you said, like say the size or say the 2p and 3p orbitals. All these are the reasons. Okay. Right. Fine. Moving on to group 2. Your question, group 1, I think they got the points, right? So for group 2, your question.
Sir, I have one doubt.
Yeah, please go on.
That same question, sir. Sir,
Sure,
can we tell that in non-polar molecular solids, they have the they have the tendency. H2O has the, I think it's H2O for non-polar molecule as well.
No, it is a polar molecule,
It's
right?
polar molecule.
Polar
So
molecule.
it has the tendency to form dipole-dipole interaction.
Exactly.
So it can be shared like that.
Yeah, see, that's what hydrogen bonding itself is a dipole-dipole interaction. Okay, HCl is also capable of forming dipole-dipole interaction, but at that time we will not call it as hydrogen bonding. Okay, hydrogen bonding is the strongest dipole-dipole interaction. Okay, so obviously that has become good. That is very efficient, right? Other dipole-dipole interactions are pretty weak, right? So that is why we say that chlorine is not, even though dipole-dipole interactions are there, but it is not, we don't call them as hydrogen bonding, because for hydrogen bonding, we take only 3 elements generally: nitrogen, oxygen, and fluorine. Okay, other than that, what other elements you have, they will have definitely dipole-dipole interaction, but it is not as strong as in the case of hydrogen bonding. Okay.
Yeah, okay.
Right, good. Fine. Your question. This is a good question. Right. Oh God, again I have to rub this. Okay, so group 2, your question is, there is something called as a property called as catenation. I hope you have heard this. Okay, so the property of catenation, when I compare oxygen and sulfur, sulfur has more catenation property. Why? Okay, the question is, why is it that sulfur has more tendency for catenation than oxygen? Why? Give me a reason for this. This is question for group 2. Yes, any answers? Group 2. Yes, group 2, any answers? Yes, no answers. Can I move on to group 3? Group 2? No answers?
Sir, don't know, sir.
Okay, cool. Group 3, you want to try?
Sir, sir, I'm not very sure, sir, but I'll try, sir.
Sure, why not? Go for it.
Sir, is it related to the bond energy of sulfur and oxygen?
Okay, so we are talking about this.
Catenation is a property of an atom to like bond with itself to form chains and rings, sir.
Exactly. Right. So catenation is a property where say yes, like this I can keep on going on all sides, but oxygen cannot do it. Correct. Why?
Sir, it's because the oxygen atom is small in size, and the lone pair bond pair repulsion is more in oxygen than sulfur, sir, making it hard to form catenation.
Okay, right. So it's perfectly all right. Right. So here SS bond is stronger than OO bond. It's a very simple answer. Okay, why is it that sulfur is able to undergo catenation? Is because the SS bond is stronger than OO bond. Now the question is, why SS bond is more stronger than OO bond? Is because in OO I am going to have repulsions happening. Right, interelectronic repulsions. The lone pair on the sulfur and the bond pair, as he said, will have higher repulsions happening. Okay, so because of this, the bond becomes little weak. Right, but in sulfur, since the size is big, the lone pair is little far away from the bond pair. Okay, so here there is no much repulsion here. Right, so thereby I can say that sulfur single bond is stronger than OO single bond, and that's the reason why sulfur has better catenation property than oxygen. That's the answer. So group 3 gets +1, Rohan. Right, okay, so I think we'll stop with this for today, people. So next class, the first question will go to group 3. Okay, right, the next class, the first question will go to group 3 and then group 4. So we'll continue.
So group 2 didn't get any points for this, sir?
Yeah, group 2 no points, they didn't answer. So that's the past question which was answered by group 3. So group 3 will get +1.
Okay, sir.
Okay, so the next question on next class will be for group 3 directly, and please study group 17 also now. Okay, group 16 as well as 17. We might finish group 16 and start with group 17 also next class. Okay, so group 16 and 17 will be your portions for tomorrow's next class's quiz. Okay, any other questions anybody has? Any doubts? Any clarity required anywhere?
Final question, the answer is the lone pair of oxygen repel each other, so the bond is not strong, sir.
Yeah, bond is not strong, so they will not be able to form undergo catenation. That's it. Okay. Any
Actually,
other
I have a doubts and textbook.
Tell me.
1 minute, sir. Group 15 regarding ionization enthalpy, I have a doubt, sir.
Tell me.
Ionization enthalpy decreases down the group due to gradual increase in atomic size, sir.
Yes, correct.
But then the order of successive ionization is expected as del I H1 is less than del I H2. But
del I
the first
H1
one should be the yes, sir. Del I H1. It should be the greatest, right, sir? Del I H1.
Yeah, del I H1, the consecutive this one. No. When I have IE1, that is the first ionization enthalpy is always smaller than the second ionization enthalpy, and third ionization enthalpy will become more than the second ionization enthalpy. Now, why it happens is very simple. Say I remove the first electron. Okay, I remove the first electron, the atomic size will decrease. Hope you're able to get the point. When I compare Na and Na plus, which has smaller size?
Na plus,
Na plus, because you removed an electron, the nuclear charge increases, the atomic size decreases. Okay, so now when the atom becomes smaller, removing the second electron becomes very tough, right? That's why second ionization enthalpy is more than the first ionization enthalpy. Do you get the point? Again, third will still be higher than the second, because again you remove one more electron, the atom becomes still more smaller. So again, it becomes more difficult.
So this is true despite, but it's NS to NP3, right, sir? You have to remove
It
from
is despite any group. All the groups, this will happen. Group 1, group 2, group 13, 14, 15, 16. All the groups, the successive ionization enthalpies becomes higher and higher. Always this happens, no, irrespective of the group.
Okay, sir, I understood.
Okay, right, fine. Any other questions anybody has?
Sir, can you explain once again about that? How do you detect the presence of sulfur dioxide?
Oh, sure. I cannot write it here again. Can I WhatsApp you regarding this? I can just write the reaction and send you. Is it fine? Can you just send me a hi in WhatsApp? I'll explain you there. Okay.
Yes, sir. Sir,
right.
Can you just tell your numbers?
Yeah, 8939
Okay.
219916.
Okay, sir.
Okay, just send me a hi. I'll explain you there.
Yeah.
Okay. Fine. Cool. Any other questions anybody has?
No doubt, sir.
Okay, till then. Thank you so much, people. We'll meet again next week. Right. I'm ending the class.
Thank you, sir.
Thank you. Thank you, everybody.
Sir.
Yeah. Thank you. Thank you.
Thank you.